What is up, 8th graders? Let's talk about glaciers, shall we? I think we should. Here we go. All right. Before we start talking about glaciers, here are some quick reminders of things that we have talked about very recently. Number 1, weathering is the breaking of rock into sediment. Number 2, erosion is the movement of weathered rock by gravity, moving water, ice, and wind. Those are the agents of erosion. Remember? Number 3, deposition is when sediment is dropped when the agents of erosion no longer have the energy to carry sediment. And number 4, weathering, erosion, and deposition all work together to shape the surface of Earth. All right, so let's start with this. Let's start with an overview about glaciers and why knowledge of them is important. Because remember, you guys, glaciers are giant masses of ice, and ice is one of the agents of erosion. And we're going to spend some time talking about glaciers, you guys, because Minnesota's landscape is prominent in terms of glacial features. That's why we want to know something about these glacial features so we can talk intelligently about what's going on in the state of Minnesota. So this is a pretty good little overview of glaciers. It's a little National Geographic video, about 4 minutes long, and I think it does a really great job of talking about what we should know about glaciers and why they're important from the standpoint of climate.
Glaciers have been shaping our world for millions of years. But as climate change warms the planet, glaciers are disappearing, not only altering the landscapes they leave behind, but changing our oceans, weather, and life on Earth as we know it. A glacier is a huge mass of ice that moves slowly over land. Glaciers can be classified into two general groups: alpine glaciers and ice sheets. Alpine glaciers form on mountainsides and move downward through valleys. Sometimes they create valleys by pushing dirt, soil, and other materials out of their way. These glaciers are found on every continent except Australia. Ice sheets, unlike alpine glaciers, are not limited to mountainous areas. They form broad domes and spread out from their centers in all directions. As ice sheets spread, they cover everything around them with a thick blanket of ice, including valleys, plains, and even entire mountains. The largest ice sheets are called continental glaciers. They cover vast areas, including most of Antarctica and the island of Greenland. Glaciers can form over years when more snow piles up than melts. Soon after falling, the snow begins to become denser and more tightly packed. When new snow falls and buries the previous year's snow, the bottom layer becomes even more compressed. The dense, grainy ice that has survived 1 year's melt cycle is called firn. When the ice grows thick enough, the firn grains fuse into a huge mass, called glacial ice. The glacier may begin to move under its own weight through a process called compression melting. As they move, glaciers erode or wear away the land beneath and around them. When glaciers began their latest retreat less than 20,000 years ago, they left behind many landscape features, such as lakes, valleys, and mountains. Glaciers provide people with many useful resources. Glacial till provides fertile soil for growing crops, and deposits of sand and gravel are used to make concrete and asphalt. Many rivers are fed by the melting ice of glaciers. The most important resource provided by glaciers is fresh water. Earth's average temperature has been increasing dramatically for more than a century. Glaciers can act as indicators of global warming and climate change in several ways. Melting ice sheets contribute to rising sea levels. As ice sheets in Antarctica and Greenland melt, they raise sea levels, adding fresh water to the ocean every day. The loss of glacial ice also reduces the amount of fresh water available for plants and animals on land. Large additions of fresh water change the ocean ecosystem as well as ocean currents. Additionally, less salt in the ocean could disturb the Gulf Stream, drastically changing the weather on land as well. Since glaciers are so sensitive to climate change, the increased speed of glacier melt is an early warning system for the rest of the planet. And if global warming goes unchecked, Many, if not all alpine glaciers, could disappear completely.
All right, that video is a great overview of glaciers, but let's dig into this a little bit. Let's get a little bit more specific with our learning. So let's start with this. 3 things to know. What are glaciers? What are the 2 kinds of glaciers, and how do glaciers form? So let's start with what are glaciers. They're any large mass of ice that slowly moves over land. There are 2 kinds of glaciers. Valley or alpine glaciers is one, and continental or ice sheet glaciers are the other kind of glaciers. And how do they form? Snow. Lots and lots of snow and very little melting, and that's kind of the key. So let's make a glacier. How do they start? Again, you guys, glaciers start out as snowfall. But there's a misconception when it comes to glaciers, and let's talk about that in our second point. In our second point, you guys, if you have a very long cycle of heavy, snowy autumns and winters, followed by cool springs and summers, the conditions are right for glaciers. So we have this misconception that glaciers, it's all about these long, endless winters, and that's actually not the case at all. You can have summer and still make glaciers. It's just that the summers have to be cool enough and the winters have to be snowy enough that you have leftover snow that keeps piling up over years and years. The heavy snow and lack of melting causes this buildup to happen, and if it keeps happening year after year after year after year, you can end up forming massive glaciers. And we've actually seen that happen in the past over and over again on planet Earth. All right, so where does the ice come from? Because like I said, glaciers start out as snow. It's not like raining ice from the sky in order to make a glacier. It's snow. Now, they talked about this in the video. They talked about the fact that you have snow. Given time, it starts to compress. Given more time, it compresses eventually into ice. So let's kind of talk about those processes. Let's start with this first bullet right here. It says, over many years of building the snow at the bottom starts to become so compacted and cold that it forms a layer of ice-like stuff known as glacial firn. And so what happens is that snow becomes more dense, and it kind of transitions from being snow to being what we might call pre-glacial ice, otherwise known as glacial firn. So if we're looking at this diagram, you have snow on top, and then over time it compacts down into firn, and then over time it compacts even more into glacial ice. With more time, the firn continues to become more compacted. It becomes glacial ice, and then you start to have a really interesting phenomenon at the bottom of a glacier. You actually start to see melting, even though it's really cold down here, even though it's all ice. There's so much weight on top of the glacial ice at the base of a glacier that you actually get water down there. The ice is getting squeezed so much that it essentially melts. It's pretty interesting. So that at the bottom of your glacier, you actually have this layer of water. Pretty crazy, I think. And that's really important, you guys, when we're talking about this question of how glaciers move. For starters, you have to have a slope. And you saw that in the video. Both alpine glaciers and continental glaciers have a slope. Okay? The combination of the icy bottom, a huge mass of snow on top of the ice, and gravity causes the glaciers to move downhill. Having a slope or having some sort of downhill is essential when it comes to the movement of glaciers. So as far as their speed, they move pretty slowly. Those continental glaciers, you guys, because you're dealing with just overall less slope, they tend to move more slowly. Where your mountain glaciers, where you have a steep slope, they tend to move a lot faster. Well, in terms of glacial speed. All right, so let's talk about those continental glaciers. These are the big glaciers. Again, these are the ice sheets. These are massive sheets of ice that covers areas. In this case, you guys, we only have 2 ice sheets on the planet now. They are Greenland and they are Antarctica. These are the type of glaciers you should be thinking about when you're talking about ice ages. When you think of an ice age, and we will talk about ice ages, in the future in this class, you're thinking about these massive sheets of ice. And you guys, we're not talking a little sheet that's a few inches thick. We're literally talking about sheets of ice that are thousands of feet thick or even miles thick. If we're looking at the glaciers that were on this planet during the last ice age, you're literally talking about glaciers that are 1 mile to 2 miles thick. Now, the next time you go on a walk and you walk a mile or 2, I want you to consider how far that is and how much ice that would be if it were all stacked up. Yeah, that's crazy to think about, but it's pretty awesome all at the same time. All right, as far as your valley or alpine glaciers, these are glaciers that form in the mountains. These are the faster moving glaciers than continental glaciers, and they're also much smaller. Valley glaciers are the reasons that mountains have ridges and defined peaks. These are the things that really make mountains look like mountains. It's the ice that forms around them because you often have cold weather in the mountains. All right, let's talk about evidence of glaciers. Okay, so now we have some of the basics. We know how glaciers form. We know the two different types of glaciers. So now let's talk about the fact that there are not that many glaciers on this planet. So how do we know that glaciers were here or there? And it has everything to do with erosion, which is what we were talking about yesterday, erosion and deposition. All right, so we can tell where glaciers used to be because, like I said before, in terms of how many glaciers are on this planet, there are not as many as there were, say, 20,000 years ago. Because glaciers leave behind evidence, there's two essential different types of evidence. They tell us a lot about what used to be there or the fact that glaciers used to be there. There's evidence all over the state of Minnesota about glaciers that used to be here in Minnesota. So these two types of evidence are erosional and depositional. Now, I'm using this bulldozer, you guys, as a little, I don't know, sort of a comparison, an analogy. The erosion, you guys, is the scooping of the dirt that you see in this GIF, and the deposition is the dumping. Now, when it comes to evidence of glaciers, we have evidence of erosion and we have evidence of deposition that tell us there used to be glaciers here. Let's take a closer look. All right, so let's talk about erosional features first. So, again, you guys, you might be trying to answer this question. How do glaciers make mountains look like mountains? Well, glacial ice is a very powerful agent of erosion because, like I said before, you guys, you can have glaciers that are hundreds or thousands or even miles thick. And if you've got ice that's that thick, it's going to do some damage. Now, you saw in the video, or I guess we haven't seen that video yet, but you'll see in a few minutes the idea of how glaciers actually do their job of eroding. So they carve. Notice how you guys, I've highlighted the word carve here. They carve rock into familiar shapes that we see when we look at mountains. Okay? What causes these erosional features? Two processes. The process of plucking, which is rock is actually picked up and plucked from the ground by the ice, and then that pluck rock scours or abrates the rock surface. So it's this two-part process. The plucking of rock by the glacier and then abrasion as that plucked sediment kind of it's like sandpaper, like you're wearing it down. That's how it works. So if we're talking about features that we could recognize as being erosional features of glaciers, these are the big six. So the following features are caused by glacial erosion. In other words, features caused by the carving and scooping of glacial ice. These things are horns, arêtes, cirques, fjords, U-shaped valleys, and striations. So let's have a closer look at those things. Here they are. These are pictures of all of these things. Now, are we going to make you memorize them? No. What we do want you to know is that can you look at a picture and determine if this is something that has been eroded? Here are some clues for you. Again, you guys, I want you to think of the words carving and scooping because that's what happens in erosion. When glacial ice is eroding, it carves and it scoops. So like this horn has been, essentially the rock has been carved away to make this shape. This arête, which is this kind of razor-like ridge, that's something that's been carved. These striations, you guys, are evidence of a moving glacier. These little lines that you see here, these have all been carved by a glacier. This is a cirque, which is a bowl-like feature carved out. This is one of the things I'm kind of showing it to you down here. When it comes to evidence, we can look at a valley, and based on the shape of a valley, we can say it's either a river valley or a glacial valley. If we look in nature, you guys, river valleys tend to be V-shaped. That's a classic valley that's being cut down by a river. But when that river valley gets filled with ice, because it might be up in a mountainous area, the ice fills in, it expands, and as it moves, it carves out what's called a U-shaped valley. So when you look at a U-shaped valley, you can say, oh, look, it's evidence of glacial erosion. And then finally, we have a fjord, which is essentially a U-shaped valley with a bunch of water down at the bottom. Fjord. I just like saying that word. Say it with me. Fjord. Sorry. Anyway, on the other hand, you guys, as we said earlier, you can have glacial features that are caused by deposition. Now, if you remember when we talked about erosion versus deposition yesterday, We know that erosion is the picking up and transporting, and deposition is the dropping of sediment. So if we're looking at the first bullet here, when glaciers advance, they pick up or pluck huge amounts and sizes of sediments. When glaciers melt and retreat, they drop or deposit the sediment they have picked up. This deposition causes many types of landforms. And we see these landforms right here in Minnesota quite a bit. And when we start talking about glacial features in Minnesota, just know that we're talking about either erosional features or depositional features. Let's take a closer look. All right. So again, you guys, depositional features are when glaciers begin to melt, they drop. There are a couple of ways that this happens. It drops because the sediment just literally drops because things melt quickly, or sediment is transported through meltwater, okay? So meltwater, you guys, is essentially any water that melts off of a glacier. And again, because glaciers are on an incline, meltwater flows downhill. And this meltwater carries sediments out and away from glaciers. And this sediment, you guys, is something that we call glacial till. So you can see where I have it highlighted here. The areas where the till collects is called an outwash plain. So if we're looking at this diagram right here, this represents a glacier. This represents the melting front of a glacier. This represents a little streams that are melting off of it. This area right here is called the outwash plain. So when glaciers begin to recede, they deposit larger sediment into piles. These piles have names depending on where and how they're deposited, okay? And the reason I'm saying that is because you're going to see that deposition is all about making big piles of dirt and rock. All right, so these are 5 features that are caused by glacial deposition: moraines, drumlins, eskers, erratics, and kettle lakes, which again are things that we see a lot of in the state of Minnesota. We tend to see more depositional features in Minnesota than we do erosional features. And that's simply because when glaciers recede and they drop everything, a lot of times they end up covering up their erosional evidence. All right. So again, you guys, here's some pictures of that. Now, I'm not going to spend a lot of time describing these things to you. Just know that this is kind of what they look like: moraines, esker, erratics, drumlins, and kettle lakes. Some of the easiest ones to identify, especially here in like Washington County, are erratics. You'll be just driving along and you'll see a boulder sitting in the middle of a field. That's not because somebody necessarily put it there. It's that nature dropped it there. So this is something that certainly doesn't belong in a big forest. I'm like, we're miles away from things where we might see a big mountain, where we might see rock like this. That means that a massive glacier moved this giant boulder, and then when it melted, it dropped it, and now it's been there for, 10 to 12,000 years. Drumlins, you guys, these are essentially big piles of dirt. Moraine, big pile of dirt. Esker, big pile of dirt that's been deposited by essentially underground water that's been under a glacier, at the very base of a glacier. And this is the other thing we see a lot of in Minnesota, are kettle lakes. It's not a coincidence, you guys, that this is the land of 10,000 lakes. Many of the lakes that we have in Minnesota are kettle lakes. There are many that are fed by groundwater, but a lot of these depressions were made by giant melting chunks of ice. So, yeah, pretty cool. So one of the things that we're going to ask that you be able to do is that we're going to ask you to be able to differentiate these erosional features, horns, arêtes, striations, fjord, U-shaped valleys, and cirques, and to be able to differentiate them from these depositional features. And one of the things you have to remember about deposition versus erosion is that the terms carving and scooping, when you see things like these sharp edges here in this horn and this arête and these big scrapes that you see in striations or U-shaped valleys or cirques, those are carving and scooping. And on the other hand, if you see just big piles of stuff, pile of dirt, pile of dirt, pile of dirt, big rock that just got dropped here, these are the things that tell us that it's been deposited. That's depositional. If it's a big pile of dirt, it's been dropped or dumped. It's a depositional feature. If it's been carved out, has a sharp feature, it's erosional. Wow, that's a bunch of stuff that I just talked about. Well, don't worry, you guys. We're going to wrap it up here. This little video, it's about 2.5, 3 minutes long, and it essentially talks about these same things, you guys, how glaciers go about the process of eroding and depositing. It's a pretty good little video, and it's kind of fun because the woman that narrates it is Scottish, so you get to hear the Scots woman say glacier instead of glacier, and that's always a great thing. All right, you guys, just go ahead and watch this video. And then, like I said, you've got some questions to answer. Great.
How do glaciers shape the landscape? Glaciers are frozen rivers of ice which have immense power. Glaciers are so powerful, they can carve huge chunks out of mountains as they flow downhill. This makes them one of the most powerful natural tools on our planet. Glaciers are sometimes called nature's bulldozer. Just like a bulldozer, glaciers shape the land in 3 ways. Firstly, glaciers pick up material. We call this erosion. Water flowing along the bottom of the glacier seeps down into the rock below. When it freezes, it opens up the cracks in the rock. This is known as freeze-thaw weathering. Then, as the glacier flows downhill, pieces of rock come loose and the glacier pulls them along with it. We call this plucking. Ouch! These rocks and stones scrape along the glacier bed like sandpaper, taking more rocks and stones along for the ride. This is called abrasion. Secondly, the glacier transports this eroded material as it flows downhill. Some of it is hidden inside or at the base of the glacier where it can't be seen, but sometimes it is transported on the top of the glacier. This is why glaciers often look dirty. As the glacier flows down a mountain, it gets warmer and starts to melt. Just like a snowman, anything which cannot melt is left behind. As the glacier melts, the rocks and stones fall to the ground. We call this deposition. By now, this material is a tasty mixture of rocks, stones, sand and clay, known as glacial till. The melted ice turns into meltwater and flows downhill to join a river or lake. Today, glaciers only exist in the coldest parts of our planet. But during the last ice age, glaciers existed in the UK too. Although the ice has melted, they have left behind some awesome scenery. As our planet warms up, many of our amazing glaciers are melting fast. So grab your walking boots and head to your nearest glacier while there's still time to see nature's bulldozer in action.